Let's look at this. Oh, yeah. Let's see. Hey, Emily, how you doing? Can you hear me? Hello.
Hello.
How's everything?
Good.
So, were you able to do some of the worksheets that I sent?
Yeah.
Okay.
Let me
Did
go
you
check.
actually like yeah, what did you guys do this week first? Like for your math class?
We had homework and we had a quiz that we did Monday and
Yeah.
yesterday,
Okay.
which was pretty good. I got 100.
Okay, that's good. That's the sum and then difference ones, right? The identities or which
Yeah.
one? And then like what about the half angle ones?
There's also the half angle on that.
Okay, so
Yeah.
you're good with those ones. You know how to do half
Yeah.
angle.
Yeah.
Oh, okay. But I was actually gonna cover both of those today just to like review it.
Yeah, we could still review.
Okay, good. Okay. And then what else did you guys do?
I think we did they have the half angle and then they have it's like pi, it's like, I mean, not pi. It's like 2. It's one where it's like 2, sine 2.
Okay, let me look at that one. I have the
Yeah.
identity two. Which one is it? Is it this guy?
Yeah, double angle.
Okay, double angle. Okay, so you guys covered all three of the main guys.
Yes.
This one, and this guy. Okay. What are you guys covering for next week? Because I know the test is next week. So you guys already did some, and then you get half and double. Are you guys,
Um, I'm actually not sure what we're doing next week.
okay. But so double angle was also in the test, you said? In the
It was in
quiz?
like the homeworks that we did.
Okay. How do you feel about this one? So you, because I know some difference pretty easy. Half angle. There's another version of this, but like it's just really applying these guys.
Yeah.
You know, I mean, all of this is the essence of it is you know how to apply them. And then the double angle, it's hard to figure out like if you were to prove, you know, obviously prove if these are equal. I think these are commonly used, but
Mhm.
we can go over it. I think for your exam, maybe we'll spend some time today on some difference and then half angle, and then like double angle. I know I have double angle. I think that's like the third one I sent you. the multi-angle one. We'll cover that like next on the second one this week. I think maybe Sunday. Okay. But you said you feel pretty good though, right? Like
Yeah.
it's not something that's super hard. Okay,
No.
that's good. Let's actually do this one first. Yeah, it's always the case where like it seems like it's very simple, but then when the exam comes,
Yeah, that's
it's
true.
always the case. Try to like maybe you get to keep the quizzes, right? And then does she gave you guys the solutions already? Maybe did she give you?
Yeah. She gave us the quizzes back.
Okay, and then like just redo those. Maybe like because like the ones that she gives you, she probably is assuming that you already know how to do them really quick.
Hmm.
And then like maybe other questions that she throws you guys, maybe, and it's always that question in the review. I'll try ask her if there's something that ahead of time so that we can actually cover more of those like similar
Yeah,
problems. Because she always throws you guys like a curveball for some reason. Like,
that's true.
yeah, I know some teachers they don't do that. It's usually just like, especially in like high school where like it's just knowing the basics.
Hmm.
Supposedly the exam is just knowing the basics. It's not like going a step further. That's usually like later on in college.
Yeah.
Okay.
Um,
Okay. Did you have any other questions or questions?
no, not really. Are we just gonna go over this worksheet?
Yeah, I was just gonna go over this worksheet because I don't want to go over all of them at the same. Did you have other questions though before we do that?
No. Actually, wait. I'm gonna join on my phone because my laptop's about to die.
Okay, go ahead. Let me know when you're ready.
Yeah, it says yeah, you just have to let me in.
Okay. There you go.
Okay, there you go.
Oh, okay. Can you hear me?
Okay, there we go.
All right, good. All right. So yeah, we'll just cover like half angle and then like review the sum difference. So when you do like half angle, really like you could do these. I mean, it's pretty cool. You can do like this decimal stuff. Exact. You can get the exact value. So like really, what I do here is, how like you have this other one. I guess there's another way of writing this guy, and you guys probably covered it. Yeah. Sure. Well, let me use another color. This one is a bad color. Let's go with like blue. Yeah, blue is better. So, when you do something like this, and plus or minus, and then this 2 right here, you can transfer it here, right? Yeah.
Yeah.
So 1 minus 2 cosine theta over 2. Same with the other ones. Cosine of theta equals plus minus. So there's 2 forms of it. And then like whichever one, I usually like doing the original one, but just to let you know that there's other forms. 10, this guy, and then plus minus, like 1 minus 2 over 1 plus 2 cosine theta. Okay. All right, so I guess for this one, since you know that this is, a decimal, I would just times it by 2 when you get up here, when you go to this guy. So this one would probably be, let's just do this. Let's say 1. Actually, hold on, what am I doing? This 2 is actually here. 2, okay. Well, you get the point. So 1 minus cosine of 292.5 times 2, yeah? 292.5 times 2 over 2. So what is that? 292.5. 292.5 times 2. It's 585. So square root of 1 minus cosine of 585 divided by 2. Okay. And typically, like when I'm looking at this, like I want to, since this is over 360, you want to convert this to something that you already know, something that, I mean, that's always the game, is to convert it to something that you already know. So 585 minus 360, you get like 225. And then 225, and then let's see, where is that at? I think that's like a 45 degrees somewhere. So when you look at the unit circle, so that's 180 going this way and then 45. I think it's this guy. So that's 45 pi over 4, and then so that's 1 minus 1, and then root 2. And it's cosine, so it's negative 1. Let's see if this is the one. So square root of 1 minus 1 over root 2. That's positive. And so that's 2 plus 2 root 2 over 2. This is 1. This is 1. And it's the square root. And let's see. So when you times this, you don't want this radical down here usually. So if you convert this, you times this by root 2. Then root 2. So let's see, that's going to be 1 plus root 2 over 2. And this is this guy right here. And let's see, 1/2. How did they get that one? So root 2. So let's say 1/2. See if we can get this one. So let's say 1/2 plus root 2 over. I think it is equivalent. So when you do, let's see. So let's see, 2 over 2. Yeah. Okay, so it's actually 2 over 2 plus root 2 over 2. And then so that right there up top would be root 2 plus root 2. And I think the 2, yeah, you do get the 2. And then it's negative, and then it's over 2. So you just apply it that way, right? And so let's actually, it's hard to delete this one here, but let's. So all you have to do is just apply that 585, which is like the 2 right here. So this 229.22, you apply this 1 minus cosine 2 times that guy over 2. And you should get, once you simplify, use the unit circle, you should get that value. All right. Let's actually do this other guy. So the next one here is very similar. What is 2 times 337.5? 675. So it's square root of 1 minus cosine of 337.5 times 2 divided by 2. So, and then when you do the square root of 1 minus cosine of 675, again, you have to find the angle itself. That's something that you can work with. So you minus 360. That's 315. That's 1 minus cosine of. Let's look at that one. So that's 315. In the unit circle, so that's 360. So that's this guy, 45. And so 1 minus 1 root 2. So cosine of that would be 1 over root 2. 1 over root 2. So it looks exactly the same. So the only thing that changes is this sign. So I would probably just change whatever you got there to this guy.
Oh, okay.
I mean, if you can relate these two guys, yeah. I mean, once you're doing it. So
Yeah.
that's all you have to do. But the steps here, when you're doing this like decimal ones, is just doubling it and then applying the sine, half angle, or cosine, whichever one. Let me. It's really inconvenient to actually delete these guys, but let's just. On my iPad, I do have my iPad, but I usually, yeah. Next time I'll probably use it again. So actually, hold up. Why don't we just. There you go. All right, so for tan is this guy, and all you have to do is just you apply it. Like, I will probably do it with a 2 again. So 105 times 2 is 210, and let's see. Let's just write it down first. So 1 minus cosine of 210 over 1 plus cosine of 210. And what is a common one there? So what is that? Like 360 minus 210, or 1. 180. Okay, so it's just that guy. So it's just 30 here. And so that's 35 over 6. So that's going to be 1, 2 root 3. And it's the cosine of that one. So that's going to be, and this is negative. Negative. This is also negative. Negative, negative. So that's going to be 1 minus root 3 over 2, 1 plus root 3 over 2, and this is plus, another one's minus, and then I guess after you simplify this, you times it by the bottom. So the reciprocal of the bottom. So So that's 2 plus root 3. Let's see. This cancels. Okay, hold up. Let me see this one. Yep, so you do times that by the conjugate. So the 2 plus 3 2 plus root 3. Oh, yeah, and don't forget this is negative, negative, negative because of this guy. And then so the bottom itself is, let's see, 2 plus 2. I'll probably leave it the way it is. So I'll just do this. Because it's squared, you're going to have that square root there. And then the bottom becomes 1. Yep, yeah, the bottom becomes 1. And then when you do this negative, it's just going to be 2 plus root 3. So I think that's the answer, yeah. And then you distribute the negative, and you should get this guy. But yeah, like for this one, again, the tan, just apply this. It's just really applying this guy and then simplifying. Sine, cosine, or tan.
Yeah. Okay, wait. Yeah, I like this actually.
It's not bad, yeah. Yeah. When you guys did that, which one did you find like more or easily? Like I don't know how you guys defined it. Did you find it this way or did you find it when you did times 2? Like because you can either divide it by 2 or times the one over here by 2. Which one did you guys do?
We times it by 2.
Like, do you apply it with this guy the way I did it?
Yeah.
Okay, that's good. Yeah, usually that's the way that's easier to compute rather than because then especially when you have like a decimal. All right, and then let's go over this other guy. I mean, yeah, they're pretty easy, but it's always just good just to do like problem by problem. So this next one right here, same thing. It's 210. So and let's say square root of 1 plus cosine of 210 over 2. And let me just see. Okay, and then so this one's negative. And then so when you do that, let's see, so it's negative, what is a cosine of 210? Root 3 over 2. 1 minus root 3 over 2 divided by 2 square root of, same thing here. You know, this 2 over 2 minus root 3 over 2. So that's going to be 2 minus root 3 over 2 times 2. So that's 2 minus root 3 divided by 4. So applying the square root at the bottom only would be 2 here. And square root of 2 minus root 3. Yeah, that's not that bad, yeah. So let's see. Number 5. This is actually a little. It's. I mean, pick your game. I think the sum difference one is easier to remember, but this one it is shorter to compute. So let's see. This next one, times it by 2 again. So when you times this by 2, it's 315. And then just apply the formula again. Let's say, so this one, negative 1 plus cosine of 315 divided by 2. And let's see, the other one was, let's see, 315, so that's 45 down here. So 1 minus 1 root 2. So let's see, minus 1 plus 1 over root 2 divided by 2. You can already see the answer. It's not that bad. So that's going to be 2 plus root 2 over 2 times 2. So minus 2 when you do the square root, and then it's 2 plus root 2. So yeah, that's really what you do. It's just really applying that and repeating all those steps. And let's do this one. Okay, let's look at this. So 337.5 times 2. 675. So 1 plus, or square root 1 plus cosine of 675 over 2. Okay, so change that to the common angle that you know. So 675 minus 360, what is that? That's 315. So that's same as this guy again. And this is 1 minus 1 root 2. But this is positive. Because it's right here. So it's positive, and so it's 1 plus 1 over root 2 over 2. And 2 plus root 2 over 2 times 2. So that's 2 plus root 2 over 2. Yeah, so it's kind of similar. The only difference is it's in a different quadrant. So it's only a sign difference. Let's see. All right, these ones. Did you actually try like I know you did some of the worksheets, but which ones did you do? Did you do some of these ones already?
I only did like the first 6, and then I was like,
this guy. Oh,
yeah.
the first 6. The first 6. Okay.
The worksheet yeah.
Okay. This one, let me see if I didn't actually go over all of them. Let me see. 10.
Because that one was like so much. The rest of those, like, those are so much.
Oh yeah, this one actually, this is like a 13, 14, 15. Yeah, these other ones. I saw this in your exam. Yeah, something kind of similar to this.
Yeah, that was like kind of like our homework, actually.
Yeah. So I think, yeah, maybe do some of these if you didn't. Let me just look at this guy first. So I know in one of you guys' homework, or the ones that I got from your teacher, you guys solved some of the some equations, right? Not just simplifying them. Let me see, 10 phi, if I can do this on 10 phi, 15/8. I think for this one, let me see. So I can just try to tackle this. Hmm. Okay, so if you did the squared, 10 squared of phi, it'll be 15. Let me see, this one would be 1 minus the equation 1 minus cosine theta, okay? 1 plus cosine theta. And okay, so let me think, cosine. I wonder if you have to do the tan inverse. I don't think you have to do tan inverse of this. Let me think. Hmm. Okay, let's just cover this. I'll look at this later on. I didn't cover this yet, but let's just do 13 to 16, and we'll cover
Alright.
these guys. I know they're. Did you try these guys? 7 to 12.
I think we like kind of did something like that today, but
Oh,
she
you guys
didn't really
did?
fully teach it yet, so I'm not
Do you
sure.
remember? I remember doing it, but like I know it's a little bit. But what do you remember from what you guys did? What did
I
you
think we did change it to negative tan. I
negative?
mean to inverse.
Oh, you did the tan inverse,
Yeah,
and you found out what the theta was.
yeah.
Okay. Okay, and then from that you found obviously once you have theta you can do tan any tan.
Mhm.
Okay. But then what about the exact value of that though? Like, so you guys found it exactly. Let me see if I can find the arctan.
Okay.
Let me just see. Exact value, because again, that's always the case. Okay, the exact form is 15 over 17. That's good, but hmm. Anyways, okay, so 15 over 17, we'll just go with that. And then, so theta equals 15 over 17. And then so 10 2 times 15 over 17. What's is that? 2. Apply the formula. Let's see if we get the same value. Okay, so 1 minus cosine of does it make sense? Let me see this on theta. Hmm. Okay, so I did confirm it's the right one. So the theta is 61.93 degrees, and then when you times that by 2, when you times that by 2, that's not exact though. let's move on. I'll show you this next time. It's just the same thing as what we did last time. We did like something similar, but yeah, you do have to get the exact value by doing arctan. I'll show you that next time. I'll actually work it out. So let's move on to this guy, which is like easier. So okay, so for this one, a bunch of this is just verifying it. So like it's really just, can you apply the, let me look at the Treg identity sheet, is applying the Treg identity and then seeing if you can get this guy. So sine 2x is your double angle identity, right? So sine 2x equals 2 sine x times cosine x. And then so this guy, you just pretty much, after you know this, put that in here, and then cancel the cosine, obviously, from what you have here. And then you'll get that, which is really simple. And then for 14, let's look at this one. 2 sine x plus times cosine x over cosine 2x. The sine 2x is the same thing. You're just doing the reverse. So you have sine 2x over cosine 2x. And when you do something like this, every time you have a sine over cosine, you can always just do the tan. So that's pretty simple. And
Oh, okay.
yeah, you can just do the tan, right?
Yeah.
Okay. Then that right there is not in your sheet, but then that's like a common knowledge thing. Because the sine 2x here, after you do that, you can expand it. But then how do you get the sine 2x? And then this one, let's look at this one. So you have 2 sine x cosine x over cosecant squared x minus 1 equal, and then you need to get this tan squared x times sine 2x. Okay, so there's this, let me look at the sheet again. So there's a cotangent, there's a cosecant here, there's a cosecant. Yeah, it's the Pythagorean identity one. So the Pythagorean identity, I think it's the third one. You get this cotangent squared plus 1 equals cosecant squared x, or theta rather. And then after that, you just change. Yeah, so when you plot that in here, when this cancels with the 1, obviously with this guy. And then you get cotangent squared x. And then you apply the double angle on the numerator. And so you get this. Or you get this guy rather, and then sine 2x over cotangent squared. And then that cotangent is just 1 over tan, obviously. And then so that's the tan squared version of that guy. Tan squared version of it. Yeah, and then that's like you replace it and you get this guy. So I mean, yeah, it's a bunch of this, like, it's not very, I think what is hard is knowing that you can do this extra stuff. This one, this one,
Mm-hmm.
Like same with this guy, right? Like this is not in your paper, this is in your, but for like when you see something like a cotangent squared, any of those, or like cosecant squared, the counterparts for those, even though it's squared or there's a 2 in the parentheses, it's valid to say that the reciprocal is, or the sine over cosine over sine is still valid.
Mm-hmm.
All right, this one. So this one, let's look at this one. So sine 2x over cotangent squared x times 1 plus cosine 2x equals tan cube x. So an obvious one is this guy. You already know it. This is your double angle for sine 2x. So replace that here. And then let's look at the denominator. Let's see. The cosine one, the cosine 2x. You also have that. That's your second double angle. So when you put that in there, let's actually 2 cosine squared. Okay. Okay, yeah. So when you plot when you have this guy, substitute that guy, the 1 cancels out, so you only have this this 2 cosine squared x, which is this guy right here, and you just times it by this guy. This is the reason how they got this. And let's look at what you're supposed to do. So you're supposed to get a tan cube x. So just cancel the 2 first, something you can do. And let's see if we can do any of the reciprocal ones. The reciprocal ones is the one that is good to like just know those. So let's look at this. Cotangent squared x, because you need a tangent, and it's cubed though. Okay, I see it already. So the cotangent squared x, that becomes tangent squared, right? Tangent squared, and then this sine over cosine. Sine over cosine gives you tan, right? So you get tan x times tan squared x gives you tan cube x, right? Yeah. It's right here actually. Does this last one make sense? It's just a bunch of those reciprocals.
Yeah, you just have to like plug in a bunch.
Yeah. I don't know if I forget if you got most of this correct in the previous exam. I know there was like a bunch of this finding the angle and simplifying, right? Or not finding finding the trig expression, and then the identity. Were you fair with the like this stuff, or did you?
Yeah, I understood it.
Okay, that's not bad. As long that the only hint, if there's any, because we covered it here, is don't only plug in the one that you know, but also like the reciprocals. Like in the end, when you get stuck, when you have something like this, look at the reciprocals. Okay. All right. Let me see. 10 minutes, but let's just look at maybe if there's an identity one. Those are always good. Okay. So for this guy, did you guys cover? Let me see if this is the one I was thinking. Oh no, this is not the co-function one. No, this is not the co-function. This is the sum and difference. Okay, so when you have like this guy, right? I mean, it's really simple. You have something added in, it's a sign. Just apply your sum difference. I think this is the addition sign one. So it's sine, cosine, cosine, sine, right? So you have pi over 2 cosine theta plus cosine pi over 2 times sine theta. And let's see. And then since you have this known value, you can, any of these ones you already know, sine pi over 2, I think that's just 1. So this is just 1. And this guy is 0. So, and then, simplify it, obviously. And then that's how they got that one. Okay. And then obviously same with this guy. If you have something over, just do what you can first and see if you can evaluate the ones where there's a given angle. So cosine pi plus theta. So this is addition with cosine, so that's cosine, cosine minus sine, sine. So cosine pi times cosine theta minus sine pi times sine theta. And let's see, the known angle. So cosine pi, what is that? That's -1. And then sine pi, that's 0. So the second term cancels out, and you're left with negative cosine.
Okay, that one's actually really easy.
Yeah, I didn't see this in your in the ones that you guys have, but I know she likes doing this verification stuff. Yeah, she does like it, but if it does come up, this is not much. I think I'll see if I can get any more. But yeah, like for these other ones, let's cover. There's actually, if you can do the number, like the worksheet number 8, I'll just show it to you. This guy. Back to sum. We'll cover this on Sunday, and then like if you have other, let me just see what it is. Each for some with positive arguments. Okay, probably with positive arguments. Okay. Yeah. So try see if you can do these. I know you've already done some of the. Did you guys even cover product to sum though? You guys covered product to sum. I don't know if that's even an identity.
I don't think so.
Okay, if you guys don't have that one, maybe it's. Let me look at number 9. Oh, solve. Did you guys solve? I know you guys solve equations already, right? Have you guys solved any equations with these guys yet? Or I don't know if you guys did that. Like when you have to solve for theta. Like this. Did you guys do
just
this?
oh yeah, like just today.
You guys did this today? Okay. Okay, maybe do
Yeah.
this one number 9.
Mhm.
And then like all the other worksheets that she gave you guys, try to like maybe repeat that before Sunday, and then we'll talk about questions that you have.
Okay.
Cool. All right. Let me know though, ahead of time. I know it may be better if you do have questions, like just let me know like in the email. If there's,
Okay.
because like she had like so many worksheets that she gave me, and I wanted to cover like high level stuff, and
Mhm.
maybe specific ones if you have any of them that you want me to cover. Cool.
Okay.
All right. Thank you.
Thank you. Bye.
See ya.